Okay, for this question, it asks us to find the value of the test statistic. Test statistic would either be the t, the z, the chi-squared. In this case, the standard deviation is only known for the sample. We don't know the population standard deviation, so we're going to use the t formula, and that is the sample mean minus the null hypothesis mean all over sample standard deviation divided by sample size. Let me fill those in. Okay, this is what we're plugging in here, and this is what we should get. You should try this on your own just to make sure that you do get this answer. And that is our test statistic. So I'm going to plug that in. Sorry, I had to stop the video there because I had gotten an incorrect answer, and turns out I hadn't read closely. I need 3 decimal places. I had only rounded to 2 decimal places, so we'll put that 4 in there. And again, anything like that happens to you, please let me know, because on a test, I don't want to penalize you for something like that, especially if I can't do it myself, right? So this is our test statistic, and then we're going to see what they ask us next. They're saying, what should we actually do with that? Well, in order to know what to do here, we need to know what the t critical value is. We need to know what this value that we need to get above is. And in this case, we have a 0.05 significance level. We have a pretty huge sample size there. So our degrees of freedom is technically 349. And we need to know one-tail or two-tail test. And it says is more than. That directional word more than tells us that we're doing a right-tailed test. If it had said is different from, that would be a two-tailed test. Is less than, that would be a left-tailed test. But more than is a right-tailed test. So right-tailed test, 0.05 significance level, and degrees of freedom 340. Now let's check out what our thing is here. So we have 0.05 in one tail, and degrees of freedom, we're sitting at 349, which we're not going to find. It's somewhere between these two numbers. I tend to go upwards just to be more conservative, so that would be 1.65 as our critical value. In other words, we need our t statistic to be further out in the tail, to be higher than this number, because it's a positive. If this was a negative, we'd have to be even more negative than this number. And we're way, way above that, so I'm going to close that. So because of this, we should reject, but both of these say reject. So what is the difference here? So reject the null because there is sufficient evidence to conclude that the average wait time is more than. This would have been the alternative hypothesis if we reject the null hypothesis because our statistic is so high. Then we're going to have to settle on the alternative hypothesis that the average wait time is above 45 minutes. So this is what we want to press here. And then both statistical and okay, so we know that it was statistically significant. So it's either going to be that and that. Practical significance is tricky. Does it really matter in everyday life? So the question is, we've already shown that it's probably true that the wait time is more than 45 minutes, but it's more than 45 minutes by a single minute. I mean, there's only 1 minute difference between what the standard is and what it actually is here. You could argue that extra minute of your time is super precious. And if you would put this, thinking that on a test, you could probably come argue that to me. I'd probably listen to that. But I would say that there's probably no practical difference between those two times. Okay, and we have a similar question here. I'm just going to skip this. all of these questions really are the same idea. So let me stop there.